All right, class, so we're going to start talking about the periodic table of elements and understanding how to read that chart. Okay, now in order to understand that though, we're going to need to know a little bit of background information first. Okay, the first thing is that there are three parts to the atom. Okay, so at the very top is our protons. They have a positive charge. Our neutrons have no charge, and you'll notice that they are found in the nucleus of the atom. And then finally, they have the electrons, which have a negative charge, and they're the ones that are surrounding our different around the elements. Okay, so let's take a look down here, and we're going to start getting an idea of how to understand some of the terminology that goes with this. Okay, the very first one here is they're going to notice that there's a whole number right here. Okay, and that's going to be referred to as our atomic number. The atomic number is going to tell us the number of protons as well as the number of electrons there are in that particular element. This is what makes each element unique. So in the case of carbon, its atomic number is 6. So therefore it'll have 6 protons as well as 6 electrons. Okay, now on any other element key, you're always going to find the symbol. So the symbol for carbon is the letter C. You're going to see its element name. So you see the name down here for carbon. And then the other number on here is you're going to see this decimal number down here. So in the case of carbon, it's 12.011. That is our atomic weight. This is the number of protons plus the number of neutrons. So if we go back up here to our model of our atom here, okay, you'll notice for carbon that there are 12 protons and neutrons within its nucleus. Okay, so now the last number to figure out is to figure out the number of neutrons. So what we're going to do is we're going to subtract the atomic weight minus the atomic number. Okay, so for the case of carbon, we're going to subtract 12. Okay, we're going to round it to the nearest whole number, minus 6. And carbon has 6 neutrons. Okay, now the best way to get to understand this information is by practicing. Okay, so what we're going to talk about today are valence electrons. And so first of all, let's talk about what a valence electron is. These are the electrons that are found in the outermost shell that do the chemical bonding. Okay, so when we draw out our Bohr model drawings, these are the ones that are sitting on the very far outside. All right, so let's go ahead. There's one real key rule that we're going to follow. And that is that in order to find the number of valence electrons, we're going to count from left to right on the periodic table in the row, or another term for it is period, in which the element sits. So let's go to the period and take a look at this. Okay, so if you look in the top left-hand corner for the letter H, which is hydrogen. If I count from left to right, I'm only going to count 1. Therefore, hydrogen has 1 valence electrons. Okay, now if I looked over towards the right-hand side of the periodic table for the letter O, O is for oxygen. And if I counted in the row that it sits in, I would count from left to right, starting at lithium, which is Li. Lithium would be 1, beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen 6. So therefore, oxygen has 6 valence electrons. Okay, there is one other rule out there that is kind of the exception to this, and is this. The elements that are in columns or groups 3 through 12, all of them have only 2 valence electrons. So if we take one more look at the periodic table, okay, this is what we have here. Okay, these are the ones to start with. Number 21, scandium Sc. And if you went all the way over to the row where number 30, zinc, is located at, that would be periods 3 through 12. and they will only, all of those below them also have 2 valence electrons.